Good afternoon, everyone. So, we have a very important guest here, and so we have Dr. Dipanjan Mukherjee, who is currently supposed to be a postdoc at Neutrino University in Italy, and to give a brief overview of his academic career till date. So, he did his undergraduate studies from Presidency College, and then he went to IIT Kanpur to do his MSc studies. After a brief stint at IIT Kanpur, he joined the IUCAA Pune, that is the Inter-University Center for Astronomy and Astrophysics, and then he held a 3 years position.
It was a 5-year PhD program.
And then after the boards, he took a 3-year postdoc position at Australian National University in Canberra, and now he's just leaving on this Saturday for another position in Torino, in Italy. So welcome to our this kind of science show, and we are very happy after hearing your talk which you just gave in SSE. So going through.
Yeah. So
thanks for inviting me.
Yes. So the first question that we want to ask you is, can you explain your science in very simple terms?
Well, the science that I do is essentially trying to understand how fluids move about in space. So simply put, our planets, solar system, sun, everything is surrounded by gas. The space may look like vacuum, but it is not empty. It is made up of very small particles that is floating around in space in molecules. And what I study is how these particles and fluids that is surrounding all of us is affected by various natural processes, and how it will behave under various circumstances. And I do this by using computer simulations. So I study the evolution of fluids around in space using computers to some extent.
Yeah. So my next question is like in the general Indian scenario, like you have very limited options, like you have engineering, medical, or very selected careers. So how did you got interested into physics?
Well, I have always been curious about understanding how things happen in nature, and I have been fortunate to have very good teachers at school as well as in university, who have always encouraged us to understand or ask questions and basic questions. So the one thing that have been always told to us is, do not assume things, even if it's written in the textbooks or even if the professor says something. Always ask questions and try to understand why this is happening. Maybe the question that you're asking will lead to an obvious answer, or maybe lead to a wrong answer, but that's fine. Asking questions is important. So we have always been taught to be naturally curious, and I have always been very curious about the things happening all around us. And that had transpired me in going into a bachelor's in science, and then my career had taken up from there.
So you mentioned just now a little while ago that you did not have a specialization in astrophysics when you were doing your masters. So what got you interested into doing specifically astrophysics?
Yes, so my bachelor's in Presidency Kolkata was on physics, and again my master's in IIT Kanpur was also on physics. So I did not have any astrophysics exposure, and which is very common in many universities in India, where there is unfortunately not an astronomy department, and there is no exposure in astronomy and astrophysics, not any special papers. However, astronomy and astrophysics is always a very interesting subject that captivates the imagination of people for a very long time. And I have also always been interested in what happens in space, mainly from outreach programs as well as very simple to understand TV programs, educational channels, where I was told about the various phenomena happening in space, and this kind of things engaged my curiosity and initiated my curiosity in understanding astrophysics. So there are also various opportunities to do some internship or summer research program in astrophysics and astronomy in India. There are several institutes where astrophysics and astronomy is given as a specialized subject. For example, the place I did my PhD from in Pune, they have a summer scholars program. So there are various other opportunities to do that. And also it spreads from word of mouth. One of your friends goes there and then he comes back or she comes back and tells you that this is a very good program to go to. And that's what had happened.
So I'm curious to know about, like you talked about, you came to know about astronomy from many science outreach programs and some science programs telecasted on the television. So like it generally happens, like I used to watch some program by Professor Jayant Nadikar called Brahman, which was telecasted on the TV national. So did you have some childhood hero which you looked upon?
Yes. I have always been very inspired by the story of Professor Nadikar, and he has always been one of my childhood heroes, and that is the reason why I had gravitated towards going towards Pune, because I have heard about him and the kind of work that he has done. I'd also read various popular books by very famous scientists like Richard Feynman and A Brief History of Time by Stephen Hawking, where these books give you the flavor of research in a very simple terms, which even a person not related to the field can understand. That is definitely my curiosity.
So you talk about you spoke about how you did computational physics as opposed to the other types of physics. So what are the challenges that you have to face while doing your research?
Well, the first challenge is in our environment, we often did not have an introduction into computational physics in the first place. I learned computational techniques and computational physics briefly during my bachelor's paper, and also during my master's where we again had a paper, but there was not enough very good environment where people would often very easily go towards computers and solve differential equations on computers. So that is one of the challenges, and this is something that you have to motivate yourself towards going into and understand or be very familiar with computational techniques. So that is one thing, and then the other challenge is of course the facilities, and we of course don't have very good access to high-end computing machines. However, as a starting project or as beginners, even a simple desktop or laptop would be good to start any simple project. What's more important is to try to go into the depths of the computational techniques and understand the basics of the techniques in the first place.
So I'm also curious, like when you joined IUPA for your PhD program. So in general, when we talk about astronomy among the public or even school children, so what people have the notion is like you have a telescope or some device which you use to look at stars and study how they shine and what happens to them and what science we can get from it. So what motivated you to take up computational physics in the long run?
As I said, I have always, while doing my masters, I have always been interested in the physics of fluids and plasmas. Plasmas is when fluids get ionized. And so when I was doing my graduate studies in IUPA, Pune, I had met my supervisor, Dipanjan over there, and he had also inspired me to also learn about magnetic fields. So how my PhD was based on understanding how fluids or plasmas in space behave in the presence of magnetic fields. So at first actually I started reading on books on plasma physics and fluid dynamics. Then I went on to understand how I can solve those equations in a computer, and then from there on I did my PhD.
So you talked about how you worked on neutron stars. So could you tell us a little more about your research there?
Yes, so during my PhD, the project that I did was something on how magnetic fields on neutron stars evolve with time. Now, there are two classes of neutron stars. Neutron stars are, firstly, let me explain what are neutron stars. So, neutron stars, so we have normal stars like our sun shining in the sky, and there are other stars which are much bigger than the sun. So sometimes when the stars run out of fuel and don't have any more hydrogen to burn, they collapse. And some of the stars, when they collapse, they form extremely small, compact, dense structures, which are called neutron stars. If they are a little more massive, then they will form black holes. If they are less massive, then they form neutron stars. The mass of the neutron star is about 1 to 2 times the mass of our sun, or as we call it, the solar mass. So these neutron stars are extremely, so imagine taking all the sun, all the mass of the sun, and compressing it into a small region of diameter like 20 kilometers. So that is neutron star. It's extremely dense, a lot of matter squeezed into a very small space, and it is also extremely high magnetic fields. And the neutrons, for example, you must have all heard about black holes. And from black holes, as we know, no radiation can come out because of its gravity. But neutron stars are also almost as dense and compact as black holes, but radiation can come out from neutron stars. So their gravity is less strong compared to black holes. That's why you can actually study neutron stars and observe them with telescopes. So my work was understanding when there is a neutron star along with the normal binary star. Matter falls from the normal star onto the neutron star. And then as it falls on the neutron star, it affects the magnetic field and it changes the magnetic field. My work was understanding how that matter reacts to the magnetic field and how it changes the magnetic field. And I did that using the computational facility available at LIGO.
So now talk about neutron stars. So we can observe them in X-rays or in radio wavelengths. So we know that the nation's first astronomy space mission, namely ASTROSAT, just completed its second year of successful operation. So if you talk about ASTROSAT, like it also has multi-wavelength capabilities, like it can observe in different bands of X-rays and UV simultaneously. So what kind of advantages we have if we use a facility like ASTROSAT in order to study some of these sources, and what are the other unsolved or very exciting problems which we have in the field of neutron stars or even pulsars?
Right. So ASTROSAT is a very novel mission that India has launched, and Indian scientists have been working on it for a very long time. And so the very unique thing about ASTROSAT, as you rightly pointed out, is a very wide coverage over multiple wavelengths. And each of these wavelengths actually addresses a different part of the physics. For example, as you said, ASTROSAT tries to observe things in the UV waveband, which tries to study things that are falling into near the neutron star, and which is a bit far off, but still near the neutron star, and forms a thing called accretion disk. Now, as the material falls from the accretion disk onto the surface of the neutron star, it gets much hotter. And as it gets much heated up, it also emits at higher frequencies. And that's where the X-rays come in. So, previous to ASTROSAT, there was another telescope called the RXTE, which was a flagship mission of this kind of science. And the very good thing about RXTE was its timing resolution. So it could measure things happening at microseconds. Now, after RXTE, ASTROSAT is the only mission that is available to the entire community of scientists all around the world that has such high timing resolution. Now, neutron stars are rotating in space. Some of them rotate extremely fast. So imagine a thing like the sun, which is compressed to 10 kilometers, but completing one rotation in 1 millisecond. So those are called millisecond pulsars, or even millisecond accreting pulsars. And to observe things happening at millisecond, you need very high resolution in time. So you need to collect data at a high frequency. That's what the very good thing about ASTROSAT is. And since it can also see the UV, so it can also collect data, understand physics happening at different environments, and study the whole bigger picture happening near neutron stars and related objects.
So one more general question, quick question which I have is like, when you talk about this kind of very exciting and very compact objects, so if you consider the Indian, the opportunities for doing projects in India, and so what kind of facilities which we have within the country in order to observe these kind of objects at the present?
So first of all, let me address one question that you had asked earlier about what are the exciting problems in the field of neutron stars and compact objects. In the field of neutron stars, was one of the most exciting and unsolved problem is what is a neutron star made of. Now, a very important thing that everyone is trying to understand is the mass of the neutron stars and the radius of the neutron stars. Because if you can constrain these two parameters, then you can constrain the physics of what is going on inside the neutron stars and what the neutron star is made of. So essentially the composition of the neutron stars. And this is an unsolved problem, and people have not done it. And satellites like ASTROSAT and other satellites launched by the US, NASA, and European agencies are trying to go in that direction. Besides that, there are various, as I said, neutron stars are one of the most exotic objects available to us in the universe. They are the highest magnetic fields, they are the most observable objects that are extremely dense and compact. So we can test the theories of physics, which is the extreme end. So neutron stars are like laboratories with conditions which we cannot create on Earth. So that's why how things happen in the presence of extremely high magnetic fields or extremely compact objects. So for example, in the interiors of neutron stars, does matter and atoms retain their normal shape, or do they get distorted? This is something that we can study by understanding the vibrations on the surface of neutron stars. So this is one problem on neutron stars, but again on this other side on black holes, like this, which is a few times the mass of our sun, what we can try to understand is how does a black hole affect a normal star near it? And when matter falls from the normal star, from the accretion disk, it also launches a jet. So a big question in this kind of systems is, when does the jet launch from the black holes? Does it depend on the accretion rate, and there is a duty cycle of the jet? And how does it affect the overall evolution of the star and the black hole? These are very some of the open questions which I study.
So we are nearing the end of this interview, but just before you leave, what would be your message to people who are studying at school, and what would be your message to them for taking astrophysics level?
And also one more quick addition which I have is like we recently conducted some outreach session, and what we gauged from the feedback is like from the undergraduate students is like they had very limited exposure to computation, to programming. And so, as you are a computational astrophysicist in general, so what is your message to undergraduate students and also from school children, so that they can improve on this side of the aspect as well, in the long run?
Right. In terms of firstly astrophysics is a very vast subject. It is all branches of physics actually have applications in astrophysics. So if you are in general interested in physics, you will find astrophysics has applications over a wide range of physics. From condensed matter physics, where you study the material of how things are made of, to extreme general acoustic effects. So astrophysics in general is very interesting. And how people can access it for, as I said, outreach programs, will be curious and try to sign up to the summer schools that are held at different places. So look out for the announcement of the summer school and the visiting programs that are available at various research institutes, and attend lectures and ask questions, and you get to know about more information. Regarding computation aspects, our first introduction to computers happened from school. I will always encourage people to be curious and be self-independent about computers and learn computing programming. When you are solving equations with pen and paper, write down the equivalent method that would happen in a computer and compare what your results are. Because once from a young age you develop a familiarity with computers, you will not feel afraid that I will have to write a program. The programming becomes a natural thing. So be curious and it will develop on yourself.
So one more quick closing question which I have is like India is part of many global consortium of international facilities which are coming up, like there are very big missions like Square Kilometer Array, the 30-meter telescope, and now we just heard it from Professor Sanjeev Mitra, and like we have LIGO-India which will be online in like the next decade or so. We have the Indian Neutrino Observatory also, which hopefully will come in near future. So looking at all these aspects and the kind of opportunities which will open in the next decade or so, what is the message for your message for general undergraduate students And where do you see India on the global scale in the next decade or in the decades to come?
So this is a very good time for students in India to take astrophysics as a profession and as a subject to pursue. Because as you rightly pointed out, India has participated in various mega international projects, and we need more students to come in and work on various interesting projects in astronomy and astrophysics. As you said, India is part of the 30-meter telescope, which will be one of the largest telescopes being built by a joint venture, various international collaborations with India playing a leading role as well. Similar in our SKA, which is called the Square Kilometer Array, which is being set up partly in Australia and partly in South Africa. India is also playing a major role and has active contributions to it. And gravitational wave astronomy at LIGO, where a detector will be set up in India itself. So astrophysics would be a very important subject to pursue because there will be a lot of openings and also a lot of job opportunities in India.
So, thank you.
Thank you very much for inviting me.
Thank you. Thank you for the